Good morning, everybody. Today we are going to be going over the rest of the questions that you can expect to see on the culminating activity. So like yesterday, I will do an example problem and then you can try a practice problem on your own paper. All right, let's get started. So on number 8, we're given two functions, f of x equals 2x plus 6 and g of x equals negative 4x plus 3. And we're trying to find two different things. We're trying to find f of g of x and g of f of x. So we do have to remember what this notation means. F of g of x, this open circle is not multiplying, it's a composition. So another way to write this is I can keep the letters in order and rewrite this with parentheses. So this means f of g of x. So as we can tell, if we write it this way, the g of x is on the inside. So what we're doing on this one is we're taking the g of x, which is 4x plus 3, and we're plugging it into f of x right here, where the x value goes. So it looks like this, 2, and then in parentheses, we would have negative 4x plus 3, and then we still have the plus 6. Once we have that, then we just need to simplify. I simplify this by distributing, so that gives us negative 8x plus 6, and then we still have the plus 6. So we end up with negative 8x plus 12. All right, so this one is in the order f of g of x. So you do need to pay attention to the order. Now, the other one is in the order of g of f of x. So if I rewrite this and put parentheses, to write it in function notation and leave the letters in the same order, this is g of f of x. So on this one, we can see that the f of x is the input. So this time, let me get rid of that. This time we're taking the f of x and plugging it in to function g in place of the x. So we'd have the negative 4, and then in parentheses, we'd have f of x, which is 2x plus 6, and then we still have the plus 3. And so then, like before, we want to simplify this by distributing. So this would give us negative 8x minus 24, and then we still have the plus 3. So that gives us negative 8x minus 21. So we would have g of f of x equals negative 8x minus 21. So notice they're not the same, so pay attention to which one the problem is asking you for. All right, now you need your own sheet of paper. Here is practice problem number 8. So try this on your own paper. Pause the video while you're trying it and then check your answer. Pay attention to what this is asking. This is asking g of f of x. So make sure you plug in the correct one. All right, hopefully you tried the problem. This one you're plugging f of x into g right here. And our correct answer is answer B. All right, number 9. F of x equals 6x minus 5. Find. Hopefully we remember this notation. This means f inverse of x. So that's the way we say that. So we're trying to find the inverse function. So remember when we're finding an inverse function, the first thing we do, instead of writing f of x, we can write this as y equals 6x minus 5. Then the thing that makes it an inverse is that we have to switch x and y. So then I would have x equals 6y minus 5. Now, these are technically inverses, but we want this in the correct notation. So now we want to isolate the y or get the y by itself. So to get the y by itself, I would first add 5 to both sides. So we have x plus 5 equals 6y. And then I have to divide by 6 to get the y by itself. And so we end up with y equals x plus 5 all over 6. Now, the correct notation we would use would be this function notation, f inverse of x equals x plus 5 over 6. And that's our inverse function. All right, time for you to try one. So on your sheet of paper, try this problem. Pause the video while you try, and then check your answer when you're done. All right, so the answer is f of x equals x minus 6 divided by negative 5, since we had a minus 5x. There's a couple different ways you could see that written because of this negative. We could put the negative in the front instead of with the 5, so negative x minus 6 over 5, or we could divide everything by negative 1 and have negative x plus 6 over 5. So all three of these would be correct. So if this were a multiple choice answer or question and you didn't see this choice, you should try to figure out which one would be the correct one. All right, number 10, find the vertex of f of x equals 3x squared minus 12x plus 7. So this is a quadratic equation, and the vertex, hopefully we remember the vertex is in the form hk, and there was a formula for us to find h. To find h, we're going to use negative b over 2a, and then once we know h, to get k, we plug in h into our equation. So k equals f of h. All right, so make sure our equation is in the form f of x equals ax squared plus bx plus c, which it is. So in this case, our a is 3, our b is negative 12, and our c is 7. So when I'm finding the vertex, I'm only using the a and the b. So finding the h value of the vertex would be negative b. So that's going to be negative 12 over 2a would be over 2 times 3. And so then this would give us a positive 12 over 6, which is 2. So the input, the x value of our vertex is 2. Now I have to find k. I have to plug in the 2. So f of 2 would equal 3 times 2 squared minus 12 times 2 plus 7. And remember, you can use the calculator if you want to simplify that. If you don't use a calculator, make sure you do exponents first. So this would be 4 times 3, which would be 12, minus 24 plus 7. 12 minus 24 is negative 12, and negative 12 plus 7 is negative 5. So that's our k value of our vertex. So our vertex is a coordinate point to negative 5. All right, time for you to try one. So on number 10, find the vertex of f of x equals 2x squared plus 16x plus 5. Pause the video here and try the problem. All right, now let's check your answer. The vertex is negative 4, negative 27. Always be careful with your signs. So when we plug it in, it should be negative b over 2a. All right, number 11. Which of the following polynomial functions might have the graph shown in this illustration below? And so we're trying to match it up with these shapes or these equations. So the thing we're looking at to decide this is where the zeros are. The zeros are the x-intercepts is where the graph crosses the x-axis. So our zeros are at 0, 1, and 2. Hopefully we remember that zeros are in the form x equals a, and we can use that to find factors, which are in the form x minus a. So our factors using these 3 zeros would be x minus 0, x minus 1, and x minus 2. However, I wouldn't write x minus 0, I would just write x. So this would be x, x minus 1, x minus 2. Now, that by itself doesn't help us that much because all of these have the same factors. The one thing we're looking out for here is hopefully we remember that when the graph touches the x-axis, like a parabola, it has an even multiplicity, meaning there's more than one of the same factor. So this is at a 1. So we know it's dealing with this 0 or this factor. That means since the graph is just touching the x-axis and not actually crossing through, this factor has to be squared. So the other ones are just crossing through. So they're just behaving like a line. So there's just one of those. So let's look at our choices. So x minus 2, x minus 1 squared. It looks like our correct choice is A. All right, next, time for you to try one. So number 11, pause the video here and try practice problem 11, then check your answer. All right, the correct answer for number 11 is B. So notice here, there is x minus 1 and x minus 1. There's two of the same factor because the graph is just touching the axis at that point. And there's only one of these factors, x minus 4. That's why the answer is B. All right, number 12. Find all zeros of f of x equals x cubed plus 5x squared plus x minus 15. This will take a little bit more algebra, but I know we spent a lot of time doing these, so hopefully we remember how. The first thing we want to do is we want to list the possible zeros. We actually don't even need to do that here. We can look for real zeros or rational zeros from the graph. So this is the first problem that we're actually going to really need a calculator, and specifically we need a graphing calculator. So we are going to use Desmos. So go to desmos.com and then start graphing. And so here's is where we're going to type in the equation. You can type it in as y equals or f of x equals, and it'll work either way. So f of x or y equals x to the third power plus 5x squared plus x. So plus 5x squared plus x, and then minus 15. Okay. So if we look at this, we want to look at the places where the graph is crossing the x-axis. This one's not a whole number, so I'm not going to use that. This one is -3, 0, and then another not whole number one. So the one I'm going to use in the first step is this one, -3, 0. So from the graph, we can see that -3 is one of our zeros. Now, remember, we do synthetic division with that number. So I'm using the -3 on the outside, and then I'm using these coefficients on the inside. The coefficient of this is 1, 5, 1, -15. Now, if this is a 0, which it should be from what we saw on the graph, we should get a remainder of 0. So to do synthetic division, bring down the 1, multiply and add, and then multiply and add, multiply and add. All right, we do get a remainder of 0. And so then this is also a factor. And since we started with x cubed, this will go down by 1 power. And this will be x squared. And this will be the coefficient of x, and then 5. So now we have 1x squared plus 2x minus 5. And the third step is once we have a quadratic factor, we can solve using the quadratic equation. So that's what I'm going to do here. This is the A, the B, and the C. Hey, buddy. You hear my son? Let me finish this problem. All right, so when I plug these into the quadratic equation, we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So under the radical, this would be 4 minus negative 20. Hey, you're okay. Almost done. And, oh, come here. So that would give us right here, negative 2 plus or minus square root of 24 over 2. However, we want to simplify this radical here. So we would break that down into prime factors. This would be 4 times 6. 4 can break down to 2 and 2, and 6 can break down to 2 and 3. And I have a pair of 2's, so that's going to go on the outside. So this is going to simplify to 2 square root of 6. So then I would have x equals negative 2 plus or minus 2 square root of 6 over 2. And then I can divide both of them by negative 2. So we get x equals negative 1 plus or minus, this would be a 1 square root of 6. Okay, so my zeros, don't forget that the negative 3 we saw earlier is included. Our zeros would be negative 3, negative 1 plus square root of 6, and negative 1 minus square root of 6. So of all the problems we've done, this one takes probably the longest. The rest are pretty quick. All right, so there's our zeros there. All right, your turn to try one. So find the zeros of the polynomial. And same thing, you're going to want to graph and then use the quadratic formula. All right, the correct answer on this one is C. We would, again, have to simplify our radical so that we ended up with these two equations here. All right, number 13, write a polynomial with the given zeros. We kind of talked about this when we did the graph. If zeros are in the form x equals a, factors are in the form x minus a. So I want to write these in factored form. So the factor here would be x minus 2. This factor would be x minus 3. This factor would technically be x minus negative 4, but I would write that as x plus 4. Now to write my polynomial, I would just multiply these together. I'm going to multiply these two together first. You can definitely use box method if you prefer. So when I do that, I'd have x squared minus 2x minus 3x and plus 6. And so then if I combine the like terms, that would give me x squared minus 5x plus 6. Okay, I'm not done yet because I still need to multiply by this x minus 4. Again, we can use box method. So I'm multiplying x squared minus 5x minus 6 times x minus 4. And so that's going to give me x cubed minus 5x squared minus 6x. This would be minus 4x squared plus 20x and plus 24. So then when I combine the like terms, we have x cubed minus 9x squared plus 14x plus 24. And so this is our polynomial. I'm going to give it a function name, f of x. This is our polynomial that has those particular zeros there. So that's what we're looking for on that one. All right, time for you to try one. Write a polynomial with the given zeros, 4, negative 1, negative 3. Pause the video and try the problem. All right, the answer here, so the factors would be x minus 4, x plus 1, and x plus 3. So when you multiply them together, you should end up with f of x equals x cubed minus 13x minus 12. All right, we got a couple more. 14, solve the logarithmic equation. These last two questions are the only two questions on the things we've been doing since we've been doing the distance learning. Everything else we did in class. All right, so solving the logarithmic equation. Step one is to isolate the logarithmic part, which is already done here. Step two is to change forms. So this is in the form log base b of a equals p. It's logarithmic. So if it's logarithmic, I need to change it to exponential. So in exponential form, it would be in the form b to the p power equals a. So that'd be 6 to the third power equals 4x plus 2. Then step 3 is to solve for x. I am going to evaluate 6 to the third power. I'm actually not sure offhand what 6 to the third power is, so I'm using my calculator. 6 to the third power is 216. So 216 equals 4x plus 2. Now I'm just solving for x. So subtract 2 from both sides. So we get 214 equals 4x. And then divide by 4. So we get x equals 214 divided by 4. Most likely our answer will be written like that as a fraction, but you can also divide it and get a decimal answer if your answers were given in decimal form. Whoops. So 214 divided by 4 is 53.5. Let me open the right thing. All right. So now it is your turn to try one. So solve this equation. All right, so let's check our answer. The answer for this one, x equals 22 over 5 or 4.4. Because we'd have 2 to the fourth power, which is 16, equals 5x minus 6. And then we just solve from there. All right, last equation. Solve the exponential equation. So this one's exponential. So step one is to isolate the exponential part. So we have to recognize that the power is x. So the base is actually e. So before I can do anything else, I have to isolate the e to the x power. And the way I'm going to do that is I'm going to divide both sides by 3. So we have e to the x power equals 19 over 3. I'm going to leave this as a fraction because it doesn't divide evenly. So I just want to leave it as a fraction rather than trying to approximate it. All right, so that's step one, isolate. Step two is to change to logarithmic form. So this is exponential, b to the p power equals a. So I need to change to log form. Log form is going to be log base b of a equals p. Okay. Now, we do hopefully recognize that the log base e is one of our special logarithms. This is a natural log. So instead, I would rewrite this as natural log of 19 thirds equals x. Then step 3 is to isolate the x or solve for x, but the x is already by itself. So that's actually our answer. X equals natural log of 19 thirds. However, on a multiple choice question, it's probably going to be given as an approximation. So let's approximate that using decimals. No, baby. So on Desmos, that's under functions and miscellaneous. So here's natural log 19 over 3. And that equals 1.85 approximately, if I round it to 2 decimal places. All right. Now let's check, or let's practice one more problem. Here's the last practice problem for the day. Solve the exponential equation 5e to the x equals 27. All right, so the answer on this one is natural log of 27 over 5, which is approximately 1.686. Now, on a multiple choice question, It depends on how many places it is rounded to, but just obviously look for the one that is closest if you don't see your exact answer. All right, everyone, now we should hopefully be ready for the culminating activity, which for period 1 will be on Wednesday, periods 3 and 4 will be on Thursday, and periods 5 and 6 will be on Friday for the seniors. All right, everybody, if you have questions, come to my question and answer session, and good luck on your culminating activity.